In the vast cosmos, is there a principle that guides how everything moves? Welcome, curious minds. Today we embark on a journey to explore a remarkable concept, the principle of least action. This theory, as invisible as it is omnipresent, is a silent director of the grand cosmic ballet. Imagine a universe where every movement, every interaction, from the majestic dance of galaxies to the path of a solitary beam of light, is governed by one single principle. A principle that dictates that nature, in all its complexity, always chooses the path of least action. Intriguing, isn't it? This principle is not just an abstract idea, it's a mathematical reality, a fundamental truth that permeates every layer of our reality. And it's not confined to the lofty realms of theoretical physics. It touches everything from the flight path of a bird to the trajectory of a thrown stone. Prepare to delve into the principle of least action, a theory that might just change your perspective on the universe. The principle of least action, a seemingly simple concept, hides a profound truth about our universe. Let's delve a bit deeper into this enigmatic principle. Imagine you're throwing a ball to your friend. You can throw it straight or you can lob it in an arc. But which path does the ball actually take? The simple answer is the one that requires the least action. But what does least action mean? In physics, action is a measure of the effort exerted by a system to move from one state to another. It's the product of energy and time. So the least action means the system, in this case the ball, takes the path where it expends the least amount of energy over a given time. Let's take another example. Consider a beam of light traveling from point A to point B. The light could take a straight path, or it could zigzag or even spiral, but it doesn't. It takes the straight path, the shortest distance, which again is the path of least action. This principle can be seen everywhere, from the course of a river to the path of a lightning bolt. When a river flows, it doesn't choose the steepest path. Instead, it meanders, taking the path of least action. And when a lightning bolt strikes, it doesn't take a straight line to the ground. It zigzags, again following the path of least action. So you see, this principle is not just a dry academic concept, it's an inherent part of nature, a guiding principle that shapes the universe. It's the universe's way of being efficient, of conserving energy. It's the universe's way of saying, why work harder when you can work smarter? And this is the beauty of the principle of least action. It's not just about physics or mathematics, it's about simplicity, efficiency and harmony. It's about how the universe operates and how we, as part of the universe, operate too. So the universe, in all its complexity, seems to take the path of least resistance or least action. While the concept may sound simple, its mathematical formulation is a bit more complex. To understand the mathematics behind the principle of least action, let's remind ourselves of what we're dealing with. We're talking about a rule that nature seems to follow, a rule that says, in essence, nature always takes the path of least resistance or least action. Firstly, we need to understand that this principle is all about optimization. In other words, it is about finding the path that minimizes a certain quantity, which in this case is the action. This concept of minimization is at the heart of a branch of mathematics known as calculus. In calculus, we often deal with finding the minimum or maximum of functions. For example, if you have a function that describes the height of a hill, calculus can help you find the highest point on that hill. In the case of the principle of least action, we're using calculus to find the path that minimizes the action. The action itself is a mathematical quantity that we calculate by integrating a function called the Lagrangian over time. The Lagrangian is a function that describes the state of a system at any given time and is calculated by subtracting the potential energy of the system from its kinetic energy. In simpler terms, you can imagine the action as a measure of how much effort it takes for a system to evolve from one state to another over a certain period. The principle of least action tells us that nature will always choose the path that requires the least amount of this effort. But remember, while we've broken down the mathematics of the principle of least action into simpler terms, the actual calculations involved can be quite complex and require a deep understanding of calculus and physics. As you see, the simplicity of the concept belies the complexity of its mathematical form. Now that we understand what the principle of least action is, how does it apply to the world of physics? In the realm of physics, The principle of least action is not just a theory, it's a backstage pass to the grand performance of the universe. Let's take a look at how this principle dances with the different branches of physics. First, let's delve into the world of classical mechanics. Here, the principle of least action is the choreographer of motion. It dictates the path that a particle will take, not based on its initial position or velocity, but rather on the principle that the action will be minimal. So, instead of tracking each moment of a particle's journey, physicists can use this principle to predict the entire trajectory, saving them valuable time and computational power. Now let's quantum leap into the realm of quantum mechanics. The principle of least action takes on a slightly different role here. Instead of just one path of least action, every possible path a particle could take comes into play. This is known as the sum-over paths, or the path integral formulation. Each path contributes to the final probability, with the path of least action often contributing the most. This principle thus becomes the backbone of quantum mechanical predictions. Finally, let's illuminate the study of electromagnetism. Here, the principle of least action shines brightly, helping physicists understand how light travels. It explains why light takes the shortest path between 2 points and why it bends when it moves from one medium to another. This principle, therefore, is the reason behind the phenomena of reflection and refraction. From the smallest particle to the brightest beam of light, the principle of least action is the unseen force shaping the world of physics. It's the quiet whisper in the ear of every physicist, guiding their understanding and predictions of the universe. It's the key to unlocking the mysteries of motion, quantum probabilities, and light paths. The principle of least action is indeed a powerful tool in the physicist's toolbox. In the end, what does the principle of least action really tell us about our universe? This principle, my friends, is more than just an equation or a mathematical model. It's a philosophical proposition, a statement about the very nature of reality itself. It whispers to us that the universe, in all its vast complexity, follows a very simple rule. It always takes the path of least action. This idea is both awe-inspiring and a little unsettling. It suggests a universe more akin to a grand cosmic machine ticking along predictably than a chaotic random assortment of particles. It implies a deterministic universe, one where the future and the past are linked by an unbroken chain of cause and effect. It's as if the universe has a clear, predetermined path, and it's merely following the route that's been laid out for it. Yet, this deterministic view challenges our usual understanding of cause and effect. We are used to thinking of the world as a place where effects follow causes. We throw a ball and it moves. Cause, then effect. But the principle of least action suggests something different. It implies that the universe considers all possible futures, all possible paths, and then picks the one that requires the least action.